Alright guys, Stephen here, and this time what I want to look at is structured versus unstructured data. Now the reason I want to do this is that there are clear benefits to working with structured data, and as we move on and look at NAPAM has a method called GET, which is ultimately going to retrieve information from network devices in much the same way that sending show commands with NetMiko did. The only thing is that ultimately the underlying spade work is done for you and it is essentially device agnostic. Okay. However, there are benefits to working with structured data that mean that as the networking industry moves on and legacy devices become thinner and thinner on the ground, that the industry is approaching a sliding doors moment from the point of view of network automation. Okay, so first of all, what is unstructured data? Okay, well, in advance of this video recording, what I've done is I have run the same script that I used in the video where we sent show commands to devices with NetMiko. This script, I've run it again, but what I've done is I've sent the command show CDP neighbors detail to every device in this topology and ultimately printed the output. Now what I'll say is I have pretty printed this, okay, because it will help me show you what I'm talking about. But if we go to the top of this here and we look at the output for the first device, once I get there, we can see that when we're returning information, that what Python sees is essentially a bit of a mess. Okay, so when you return unstructured data, you get this. Okay, now this is readable under normal circumstances on the CLI. The \n's wouldn't be visible, but Python sees these. Okay, now the issue that this presents to us is if we want to extract a specific bit of information using unstructured data, we have to get involved in loops and conditionals and look for specific bits of information. So for example, if I wanted to run show CDP neighbors detail on these devices and go and get the device ID from the output of each device, I would have to in my script I would have to say, right, well, get rid of all of this and all of this and all these lines and just give me this bit of it, or just give me this bit of it. Okay, now the issues with that, well, you're getting involved in loops where you don't necessarily need to be, and you're at the behest of Cisco's output format. So if Cisco update the iOS version and this output even slightly changes, then because your script is based on output in this format, that script potentially becomes completely useless. Okay, now when you compare that to structured data, which I'll show you in a moment, everything is very uniform. Things are in preordained places, and that means that ultimately you can access them more easily. So data will be ultimately in dictionaries, okay, and you can access specific bits of information just by referencing the dictionary key and having the value returned to you. No getting rid of lines, no getting rid of white space, much easier. And when you do it, your scripts can be genuinely dynamic, so they can proactively react to output. Okay, so let's say for example, rather than show CDP neighbors detail, you wrote a script that essentially went and got the spanning tree root bridges from all of your devices, and you wanted to then check that the spanning tree root bridge for a given VLAN was on the device that it should be. You can write a script that will react to the situation where the root bridge is not where it should be. Okay, whereas with this sort of output, it's still possible, but it's a lot more involved and a lot more tricky. Okay, so as I say, this is pretty printed. On the CLI, we wouldn't see things like the \n and so on and so forth, but this is ultimately unstructured output. Now what I'm going to do is pause the video. What I'm going to do is add in to this script one tiny little command or one tiny little instruction, and all it's going to be is use Genie equals true. Now the Genie Parsers are unbelievable. If you've not looked into them, I strongly advise that you do, because it will essentially take unstructured output, and rejig it so that it's presented to you in a structured manner. Now, once you start getting structured data, you'll get ideas for scripts that are just so much easier to actually execute than they would be if you were working with unstructured data. So that's all I'm going to change about this script right here. What I'm going to do is run it now, and we'll come back and we'll see what the structured output of show CDP neighbours detail looks like in comparison to the unstructured output. Alright, so this script has now run with the use_Genie equals true command in there, and we can see that we are being returned output that is drastically different. Okay, now when you look at it immediately, you can see curly braces, so you know that you're talking about Python dictionaries, and you can see things like colons with values to the right of the colons. So what you're essentially getting here is a series of nested dictionaries. Okay, but because it's nested dictionaries, it's much easier for you to go in and get this device ID. Okay, you can just reference its position within the dictionary and Python will return the value. Okay, so you could look up device ID for the first device that core 1 is connected to. So core 1 has 3 entries here. See the top level key is called index. We've then within that got 3 entries. Total entries displayed is 3. Well, if we look at this, we can see that core 1 has 3 directly connected CDP neighbours. Okay, and that's reflected in the output of the script with the use_Genie equals true command in there. Okay, so the Genie parsers do a lot of the legwork. What I will say is the devices are not returning structured data. The Genie parsers are doing all the work for you, but because they've done such an unbelievable job, there's thousands of Genie parsers, and it means that you can really easily go and get a specific bit of output for a given command. Okay, now as I said earlier, what this means is that when you get an idea for a script, so for example, if you did want to go and run a script that would get the output of show spanning tree for a given VLAN, you would really easily be able to access the MAC address of the root bridge for that VLAN, compare it against the MAC address that you're saying the root bridge should have, and based upon whether they match, your script can then dynamically react to that. Okay, whereas with unstructured data, you can still do it, but it's a lot more difficult. Okay, now to give an example of this in a practical sense and to show you how I kind of challenge myself to work with structured data, what I've done is I've written a little script that will essentially run show CDP neighbours detail, but then use the output of that command on all of these devices to dynamically build a network diagram. Okay, now I'm not going to talk through all of this because ultimately it involved me going and learning a couple of Python libraries, or the basics of a couple of Python libraries, and a tiny little bit of graph theory in order to actually be able to do this. And that is not the end goal here. It was just to be able to work with structured data. So I'll not talk through this, but in broad terms, this is what it does. In graph theory, a point on a graph is called a node. Okay, a link between 2 points on a graph is called an edge. Well, that means that we can map that roughly to network topology, where the devices are the nodes and the actual Ethernet or fiber links between them are the edges. Okay, but in order to do that, I need to be able to extract bits of information, i.e. host names, from the output of CDP commands. Okay, so with unstructured data, this would have been a lot more difficult. With unstructured data, it would have been a lot more difficult than it is with structured data. With structured data, I was essentially looking up dictionary values. There was no messing about. Okay, now I'll put all of this on my GitHub if you want to go and look and have a look at it, what it's doing in more detail. But ultimately, all it's going to do is go to every device, get the CDP information, extract the host names of every device that a given device is connected to, and then add a link between them, and then represent those nodes and links on a graph. Okay, and what it's going to do here is output it all to a file called diagram_neato.png. Now, Neato is just the format of the graph that I'm using. It's the one that ticks the most boxes for me in terms of how it looks and everything being represented. Okay, and what it will do is it will save it in this. We'll clear this. It will save it in this directory. Okay, now I'll run this. Okay, and I'll pause the video whilst it runs. Okay. Okay, so that script is now run. We can see ultimately all it did was go and get CDP information from every device in the topology. But if we open up this directory, then we can see that there's an image file here and it's drawn. Now, it's not the neatest. I have got another script here that will make it a little bit neater, but it's less aesthetically pleasing overall. All of it will go into my GitHub, so you can have a look at both of them. But we can see here that this script is gone. It's gotten the device name for every device. It's gotten the device name for every device that each device is connected to. So we can see here Core 1 is connected to Distro 1, it's connected to Distro 2, it's connected to Distro Core 2, and then it's drawn the links in between them. Okay, now this amounted to nothing more than really one loop or two loops maybe, and then looking up some values from dictionary keys. Okay, now just to prove my point, okay, what I'll do is I will go into this topology, and on access 3, let's shut down a link. Okay, so access 3 is here, and let's say we'll shut down gig 00. Okay, so we go into gig. Okay, so we'll shut this down. Okay, now when we run this script again, it should dynamically react to that. Okay, now I'll allow a little bit of time for spanning tree to converge, but this is hopefully just going to run the way it has been and the way I expect it to. Now, overall, the benefits here of structured data, if they're not already immediately apparent, they will become more and more apparent as we start to use devices that have proper APIs. For example, Cisco Nexus devices, they have an API that when you enable it, you can ultimately send API calls to devices that will contain show CDP neighbor detail or show run or show IPInt brief. Okay, but what those devices will return to you is structured data, but the device itself will be sending structured data. It's not going to be reliant upon a tool that takes unstructured data and reformats it, okay, into a structured layout or in a structured manner. Okay, so you're not at the behest of Cisco's output format. Your scripts aren't going to break, so you can write scripts that are going to be dynamic, okay, or reactive to the output of the script, but you don't have to worry about that script at a later date breaking and not doing as you expect. Okay, now spanning tree should have reconverged by now, so I should have reachability to access 3 again. So what I'm going to do is I'm going to run this same script again, and we will have a little bit of, we'll have a look at it once that's run. Now the only other thing I'm going to do here is I'm going to change the name of the script to closed, because we've closed down a link, okay, so that we ultimately don't overwrite the original image file, and we can compare the two side by side. Alright, so I'll be back once this runs. Okay, so this script has now run. We can see here that it ran essentially the same script again, plotting.py. We closed down a link, we ran the script again, and if we go in here, then we can see diagram Neato. Let's open this, but open it side by side. So we can see that access 3, the device where we shut down one of the links to begin with, it had 2 links going to distro 1 and distro 2. Now what we then done is on the access 3 device, we shut down gig00, which is the link to distro 2. Now if we go back in and we look at the new diagram, we can see that access 3 only has a single link and it goes to distro 1. Okay, so this script has dynamically reacted to the change in input that it was given from NetMiko ultimately, and the output or the net end result corresponds to the change in output from NetMiko without any intervention from me, and that is the benefit for me of structured data in a nutshell. Whether you're doing this or you're writing a script to check where your spanning tree root bridges are, it doesn't matter what the specifics of the script are. Structured data allows you to write truly dynamic scripts. All right. Now next time we're going to look at NAPAM, and this will be prevalent again because NetMiko's get method is going to return structured data to us. All right. Thanks very much.